Okay guys, welcome back. So today we're going to continue our dynamic particle system series. We're going to be looking at specifically adding interactivity today. So we're not actually going to do a ton of new visual generation, but instead we're going to focus on a little bit of work with chops and DATs to give us some utilities to use when we're adding interactivity. We're going to look at Kinect as the form of interactivity that we'll be adding today. But really this method is going to extend to whatever types of interaction you want to define. So Kinect is really just going to be a placeholder, and potentially we'll look at some extensions or other types of interactivity in the future. So like I said, we are starting exactly where we left off, part 4, adding our attractors as agents. What we're going to do overall, I don't have any of this set up yet because I'm just going to go through it live with you guys. We're going to add a Kinect. We're going to create a component that is then going to help us map the Kinect channels to a range that we want in a really nice user-friendly way. And from there, we will take the mapped Kinect, input it as attractors a couple different ways, and finally set up a very basic extension to handle some of the mapping and make it a little bit more scalable for us to use in other projects in the future. So, with that said, let's jump into things. If you notice that this looks slightly different from exactly where we left off, that's because I couldn't help myself before this and was playing around a little bit. All I did was add this transform. And yeah, so this is literally exactly where we left off last time. I added this transform, and it actually is kind of cool. I like how if you have the tile set to repeat, then you kind of get this effect at the top with a large black space in between. It adds a little bit more interest, so I'm going to leave it like that for now. But that is purely aesthetic. All right, so first let's get a Kinect. So I'm going to assume that everybody has a Kinect or has access to one. But if you don't, I actually have some recorded Kinect data that I can share for my Patreon subscribers. So even if you guys don't have a Kinect of your own, or for whatever reason you can't access it, you'll be able to download that trial data and follow along. So grab that if you need to. Obviously, if you haven't done parts 1 through 4, pretty important if you want the effect. But actually, if you're just joining us, most of what we're going to do today doesn't really depend on a ton of this background as far as the dynamic attractors. We're just kind of using this as a good use case. So we have our Kinect. Often when you have the Kinect first drop down, you'll have to move back, stand around a little bit, put your arms kind of out to a T, and that's so that the Kinect is able to snap to your skeleton and begin the skeleton tracking. And we can see here in our Kinect CHOP, which is what we'll be using today, all of our different channels. Now, a really simple way to add your Kinect as attractors would be to just use a select chop and then select maybe, well, actually, I'm not going to do the simple way right now. We're just going to do the proper way because that will be more efficient. So let's instead select just our hand R channels. Oops, hand R channels. And you'll notice I'm using pattern matching. So if I view my chop, template, I want to display. We can see all of our channels here. And so you can see that we have a channel name format that is P1/. joint, let's say, and then the actual data point for that joint. So for our hip, we have our hip TX, hip TY, hip TZ. This P1 is for player. A Kinect V2 at least can actually track up to 6 players. So obviously there's just me right now, so there's just one. But that's why you have the P1 prefix. And then all of your different joints have their requisite names and TX, TY, TZ. A couple interesting things on Kinect that I'm not going to really go into the usage of, but do just want to call out so that you guys know that they are there. One, right now we're outputting world space positions. We can output color space positions if we wanted to. This I find to be somewhat harder to reason about sometimes, so I don't use that a ton. We can also output depth space positions. This one's kind of cool. So interaction will basically just pulse if your hands are open or closed. So you can see now if I'm closing my left hand and opening it, those channels are pulsing. Same with my right. It's a little bit finicky. I haven't actually used this in anything like production, but it's kind of cool and can definitely be some interesting effects that stem from it. So definitely wanted to call it out. And then the last thing I think is if you use the seated, so let's turn off interactions, turn on world space positions, and go to our full skeleton. So this is all of our joints, which includes feet, ankles, etc. If we go to a seated skeleton, then we're actually going to have only part of our total data, although it doesn't really look like it's updating right now. I'm not sure why, and I'm not really going to spend the time on that. So if it doesn't work for you, then maybe there's a bug somewhere. But seated should give you like half a skeleton for upper body only. And then last, we have some smoothing that we can do inside Kinect, or inside the Kinect CHOP. So that's helpful in case you're trying to fine-tune your joints a little bit. So that's all on the Kinect top for right now. I may do a more in-depth look at the CHOP later, but that's all we really need for now. So we're using pattern matching to grab the hand R channels. So because there's all these channels, I only want the hand R right now. So asterisk hand R underscore R asterisk means select any channel name that has hand underscore R anywhere inside of it. If I didn't have the asterisk afterward, it would say look for any channel ending in hand R, which is none of our channels because of the TX, TY, TZ. So we need to have that second asterisk. And if we move the beginning one, it's saying look for all channels starting with hand R, which also doesn't work because of our P1. But for example, if we did just want the player one, then we could just add that. And now we're looking for all channels that start with P1/hand underscore R. But I'm going to leave it as asterisk hand underscore R asterisk. All right, cool. So as you can see, and I'm going to turn off this view right now, and I'll add a trail. As you can see, these values are a little bit jittery, which we can add some smoothing to fix, but they're also just somewhat random ranges. Not quite random, but the ranges are not necessarily mapped to any interval. That's problematic when we are trying to associate things, map a Kinect joint location to a parameter or for an attractor, for example. We really want to be able to have our output from Kinect mapped to a range that is known so that we can then go and take that known range and remap it to whatever our parameter ranges are. So that's what we're going to be focusing on today. We're going to be building a component that will let us kind of listen to our Kinect channels, select which channels we're interested in, and then remap those channels to a dynamically calculated range. That's going to be real nice in letting us easily set up and map Kinect to different things. So, I am going to set up a component to do this. So I'm going to select my trail and drop that down, and we're going to leave our pretty pictures for now. Okay, so let's think about what we need to do here. We're going to need to read in all of our data. We're going to need to select the data that we're interested in. Then we're going to need to listen to what the data from that channel is over an interval. Use that interval to create a min and a max range for that parameter. Then normalize the parameter on that interval and output the normalized parameter values in real time as more Kinect data is read in. So this is going to be, as I mentioned, pretty CHOP and DAT heavy. There's going to be actually a lot of pretty interesting and helpful techniques that are useful in tons of context outside of the one that we're working in right now. So I think it'll be really beneficial for everyone, but do just want to call out it's going to be less aesthetic focused this time and a little bit more focused on infrastructure and workflow. So let's first just set up the broad strokes of our kind of remapping. So to do that, I'm going to start customizing my component already. And here's what we need to do. A handy way to track something and then run a measurement is to use a trail. A trail with a window length that is whatever you want your capture window to be. So open my parent parameters. I just created a window length custom parameter, and I'm going to set that to 4. Or maybe I'll default it to 10, and I'm going to clamp them into 1. This is going to be the actual number of seconds that we're going to be listening for. Then, out of this trail, I can take and analyze, change the function to a maximum. Maybe I'll do just one channel for now. So this is my hand R, TZ, which is moving as I'm going. There we go. Forward and back with my right hand. So then our analyze we can set to maximum. We'll copy and paste that, set this one to minimum. Rename to max and min. And now we already have a dynamically calculated min and max for our two, we have a dynamically calculated min and max for whatever channel this is. So we can rename to min and max, just like this to keep things clean. And actually, we need to have a null, so I'll just change these names real quick. I'll add my nulls with Alt-N, and then I will change these to max and min for operator names. Cool. So now we have these min and max for our operator over a 4-second period, or whatever second period we want. And that is the basis for what our remapping is going to be. So now that we have these values, we can reselect our chosen channel, we can use something like an expression. Wire in both of these, our min and max, to our expression. And then say tdu dot remap me dot input val from. So this is, we're going to remap this input value, which is our real-time hand RTZ. We're going to map that from our second input index 1, sample channel 0, I think sample 0. Let's see if that works. And then just onto the interval 0, 1. That does work. That's great. So just to reiterate here, we'll go through that again. Me dot inputs. In this case, for the minimum, we actually want this, well, first input, and I'll just switch these so that our min is before our max. We want our first input, we want the first channel of that input, and we want the first sample of that channel. And then for our max, it'll be our next input, again, first channel, first sample, and then our output range will be 0 to 1. And now we can see that as my hand is moving throughout the Z range, it's going just between that range 0 to 1, which is really handy. And now we can go map this parameter, knowing it's in the range 0 to 1, to whatever we want, and have a nicely mapped value. So that is at the high level, or one case, I guess, of what we're going to be doing. We're just going to be setting this up a little bit more scalably. All right, so how to make it more scalable? Well, first, we probably want to be able to do this with multiple channels. First map the Z channel, TZ, then map the TY, then map the TX. We want that to be pretty easy. We need to be able to store our min and max values for different parameters, do the remapping automatically, and all of that is going to require some DAT usage. So we have our channels going in. So first, maybe we can use this loop to set up what is going to be our kind of calculation for each of our channels. And then we can just set up some functionality that's going to have the ability for us to drop down and select different channels that we want to be mapping actively. Okay, so first we need to set something up that'll actually just let us grab our channel names. So for that, I'm going to take this in. I'm going to middle mouse click to drop an unconnected, or connected to the in, but not connected to this select operator. And I'm going to name this chan list. Now here we're going to do something pretty cool. That is set up a parameter. We're going to call it active channel. The type is going to be string menu. And then for our menu source, we are going to set it to chan list. Now if we open our parent parameters, whoops, not quite. I believe we need to delete these first, and then we can set this to chan list, so that is a single period slash, because the chan list operator is inside of the component that we are editing. chan list, and I think, okay, maybe, no, I believe this should work. Oh, right, okay. Sorry about that. I forget or remember what I was doing. We need to grab, yeah, okay. So the correct way to set this source is with op, and then we call our operator, which is, in this case, period slash to get the child, and then the operator name chan list. Then we want the parameter dot par called chan names, and that is this list, a list of all of our channel names. It needs to be a select operator, by the way, for this to work. So now, in our parent parameters, we're able to select from this drop-down list and choose an active channel for us. And that's super handy. Okay, so now we want this select to be our active channel. So now, as we're changing our active channel, we can see that our mapping here is changing, or rather, our select is updating, and we are using the trail to calculate a window of this new parameter and then running the min and max over that window. Okay, a good start. So now, if we're going to record what the min and max is for, a given parameter, we'll need to be able to save those values. So, to save those values, we're going to need to start working with some DATs. Let's first drop a table DAT, and we'll call this selected channels. These selected channels, this is going to be empty, and we're actually going to use this table as kind of our record storage place as we go. To fill up this, we're going to need to give ourselves a little bit of functionality. So as we're going to be working with a little bit of Python, I'm going to create a extension. I'm going to call this channel map extension. Then initialize it and edit it. Don't recover, I guess. Recently downloaded VS22. I'm not in love with it. If anybody has ideas on how to, I don't know, make it work more like VS19, that would be great. Anyway, so yes, I'm going to be using a extension to manage a lot of our functionality here just to keep things clean. So we can get rid of all of this. Don't need it. Don't need it. Don't need it. Cool. So we have our extension. What we are first going to need is a method that's going to add some selected channels here once we select a channel in our active window. So basically, whenever this active channel updates, we're going to want our table to have some rows added to it. So I think first we should probably have a parameter called listen. That will be a pulse parameter. So add. Now, if we press listen, we're going to want to add our whatever active channel is selected to our selected channel table and then start listening to it. So we can do this in a couple ways. First, I will drop a parameter and we'll just get listen. In here, we will define a function, def, and then we can call this maybe add channel self Now, it's important when working with extensions that if you want your functions to be callable regardless of where you are in your project, then you want to start with a capital letter so that these functions are going to be promoted. If they start with a lowercase level letter, then these methods are going to be treated as private, and so you won't be able to access them from outside the component, which is not generally what we want. So I normally have promoted functions that start with a capital letter. Add channel, and then to add this channel, we will say our channel will be equal to self.ownerComp. So self.ownerComp is going to be our parent in this case. Self.ownerComp.par.active channel.eval. So that will grab our active channel parameter. Now, we want to make sure that whatever we have selected isn't something that's already in our selected channels table. So we'll say selected channels is equal to, and then here we're going to use a list comprehension in Python. Sorry, I should have. Whoa. Don't know what I just did there. I should have zoomed in. Sorry about that. Hopefully you can still see. So selected channels, and then I'm going to use a list comprehension. And the list comprehension is going to let me read in the text of our selected channels and then split it into a list. So I'm going to say a.split r, and I'll go through and say what I'm doing here in just a second. For a in our op selected channels, dot text dot split n, just like that, and then we can say debug selected channels, and then now I will, in a text stat, we can just say parent dot add channel. Try running this. Doesn't work. Why doesn't it work? No attribute, add a channel. I believe there should be. channel map extension has no attribute add channel. Interesting. Now, why isn't this working? What did I forget to do? This should be runner comp. Pretty sure that should be that. Interesting. Interesting. We do have our extension. Okay. Sorry about that, guys. I see what the problem is. So the actual extension wasn't the file that I had opened. So I'm just gonna copy and paste all this. I'm gonna overwrite my extension. And now I think this should work. Clear that. All right, cool. So now going to edit this file and kill it, reopen it, recover. Like I said, new VS Code. Giving me all sorts of issues. Really not a fan. All right. So now I believe interesting. All right, well, be frustrating. I guess I'll just have to be careful of that. So you guys shouldn't have this issue. I think it's just related to my VS Studio, which I apologize for. So I'm going to just do my text editing here, and then I'm just going to copy and paste over to this extension, which is somewhat unfortunate. Maybe if I turn autosave on? Well, anyway. So now, if we go in, we can see, yeah, all right, sorry for that aside. So to reiterate where we're at, we are trying to add selected channels to our selected channels table every time we hit listen. So we should do selected channels, op, selected channels dot append row, and then in the append row, we can have chan like this, and now we'll print our selected channels. Let's see what's going on. Right, because I have to do this. Sure. Okay, so now we can see this is working as we have our parameter. We can change our selected parameter, and if we run this, we see that it's added as a row in our selected channels table, which is ideal. Now we just need this to happen when we press listen. So that's pretty easy to do. we can just do a chop execute and say if channel.name is equal to listen, then we're going to call our parent.add channel function or method. So now if we make sure that value change is turned on, we can try setting a new channel again and pressing our listen, and there we go. We can see this is adding. Now it's adding twice actually because this is an on value change, so it's calling it once when it goes from 0 to 1 and once when it goes from 1 to 0. So we actually probably would rather have this in on, off to on, just like that, and we'll just turn on, off to on, and now open parent parameters, we'll check a totally different one. Nice, now we're just adding one row each time. Yes. All right. Now what? So now we can add this row. Oh, right. Why did I add this? So let me see. We can see that our selected channels are coming out somewhat crazy. So if I, oh God. All right, I'm just not gonna edit in VS Code today. Oh shit, I can't do that either. All right, text port it is. All right, so if instead do selected channels equals selected channels dot text, we can see with Alt T to open our text port, which I'm already in here. Right, so we'll run this. Here are all of our channels. We want these channels to be in a list so that we can check our new channel against them. So what we need to do is get these channels into a list, and we can do that by splitting on this function, I believe. Try this again. So this isn't quite working, and I think that might be because of the p1 slash, which I'm going to deal with here by just simply adding a rename. Rename from p1 slash to simply star. So this, I'm saying rename everything that starts with p1 dash star to just whatever it is without the p1 dash. So we're losing p1, and we just have our different channels. Now, if you're having multiple players, probably won't work, but I only have one, so I'm going to do this. Now is probably a good time to add a method to our extension to let us clear our table. So if I edit in our textport, right, textport. Okay. So we'll add a totally different method here. We'll call it def clear selected chans. And here, all we need to do is add a member. Selected channels, and we'll call that op selected channels, so that way we can just reference this self.selected channels, and that will actually give us some more modularity in case we want to change that at any point. Dot clear. Maybe we can give ourselves then a button with a null, and then a chop execute. And this chop execute can also be off to on. And in our off to on, we will call our parent method clears selected chans. All right, and we'll change the button to a momentary and see if it works. Yep. And we'll see if it works. All right, very good. It did. So now we can clear our channels. I will name this clear table. So we have that. Cool. So now that our table is cleared, we'll notice that our active channel list isn't updating. The reason for that is because we need to basically pulse the entire component to get those to update. So we can use an what can we use? We can use a chop. No. I think what we want is a DAT execute, and then a chop to DAT. From our in, we want the names. Then I'm just going to select just our first row. So this is going to be just our names. Call that names. Then we can drop that onto our DAT execute. We'll make another function in our extension. You'll notice we're putting all of our actual logic and functionality in our extension, and then just calling extension functions in our execute DATs. So this function, or method rather, we will call update channel list parameter. And so here, all we need to do is self.owner comp dot allow cook equals false. I think actually it's allow cooking equals false, and then equals true. And then we're going to want to call this on a table change, so that anytime our table changes, meaning anytime the names of our channels change, or new columns are added or taken away, we will repulse this parameter list. So we'll call that function here, parent dot update channel list parameter. And we can see if that works. Oh, so actually it shouldn't be our in1. It should be after our rename. So I'll drop a null after the rename and put that on our chop 2. And now we actually should be able to see if this worked or not. It did not work. So maybe that's because we're using the wrong method. So I'm just going to open up the help and look for my cooking. Allow cooking. Maybe we can. Yes, very good. It is working. So when we put in our noise chan1, we can see that this now updates, so we can select chan1. If we drop in our Kinect instead, we have all of our Kinect channels to choose from. So, nice. That is working as we wanted then. We'll do some cleanup later, but maybe I'll just collapse these and say channel parameter updating. And then I'll just jump in here and I'm just going to have to change this to parent 2. And that should be good for that. All right, cool. So now our parameter updates as we change our channels. So we will. Oh, actually, it didn't work for some reason. I bet I know. Yes, that's because our channel list was using the wrong or like rename channels. So that's what was giving us issues. And now, yes, we can see we are selecting our channels appropriately, and this is working. And everything else seems to be working too. All right, so we are getting there. Now we're able to, using our parent parameters, we can set a channel and then listen to it. And then as we listen to it, we add it to our selected channels table. And that allows us to keep a record of our various channels, which is great. So, a couple other things we need to do. The whole point of going back to this, can I do this? All right, cool. So now we can have our output below. Right, the whole point of doing our selected channels is so that, okay, I guess it doesn't work, is so that we can read in the channels and make sure we're not duplicating anything. So this is what, when there's a single channel, just go in and manually delete these, delete. When there is a single channel, this is what the output is. Or this is what the output is. And so we need to find a way to reduce all of this and just get it down to this ankle L TX. So that is why we're using these splits in the list comprehension. It's so we can take our channels that are split on N, which is a new line, whoops, there we go, going the other way, going the other way. Yeah, okay, cool. So I had my slashes going the wrong way. If we use a backslash instead of a forward slash, then we can see the split function is working as intended, and it is breaking our text string apart into an array where each element is the parts of the text string that are split when you slice it based on the input characters, which in this case is our new line. So with just this line, we get something that looks like this. Now we want to grab for each of these entries just the part before the backslash R. And that is what this section does. So that is why, if I go back to here and hit this again, now we can see that our processing is correct, and we're just getting this list of whatever our channels are. So to avoid the duplicates then, we have to do this. If chan in selected chans, so if it is, we don't really want this. We can then create a message box using UI.message box. We'll name it duplicate channel, and the message will be channel already recorded. Do you want to override? And then all we have to do is add our button to the message box. So we can say buttons equals, and then a bracket. We can add two buttons, one with no and one with yes as our options. Close our message box, and now A is going to be the selection from the message box. So if A is 1, which means if they want to override, this would be if already recorded. If you want to override, then if you want to override, then we can override. We can come back to that. And if not, we want to pass. And then if we're not already recorded, then we definitely want to record. And so this will be where we want to add our channel. Self.selected channels.append row, and put our channel in between open close brackets. And then I don't think we need this debug anymore. And so this should only allow us to add a channel when we don't have a duplicate. Let's see. Okay. Seem to be getting some errors. TD base comp has no attribute add channel. Very interesting again. I don't think this is my extension doing it. All right, I'm just going to get rid of this else. We don't actually need it, and I think it might be causing an issue. Indentation. So we can just debug something if our override selection is yes, yes, override. Because I think we're getting an error because we didn't have anything in this conditional. So now, if we try and pulse, oh, nope, we got another problem. Do. Name selected chans not defined. There you go. So our selected chans not defined. Why is that? In line 14. And there we go. Because I was using selected chans instead of selected channels. Like an idiot. All right, will this do it? All right, so now because we're trying to add this channel, which is already there, we got this nice message box. Do you want to override? No. And then nothing happens. Do you want to override? Yes. And now, for now, we are just printing yes, override. Do you want to override? Yes. So that's working. Very good. Clear this. Whoops. Okay, so now we need to do the recording part. To do the recording part, I'm going to bring my listen back here, actually. And we want we're going to use a timer. So I'm going to just drop a timer from my listen. And this is going to be wired into both initialize and start. We want to have our window length be our length here. We're going to define a new function in our extension, and that's going to be initialize timer. We're putting the self, by the way, in parentheses here because this is how you define class methods in Python, just in case that was a question. So initialize timer. Let's add another member, call it self.timer equals op timer 1. Then we can say self.timer.par.initialize .pulse. And that will initialize our timer. We can then grab we'll use a parameter execute. We can say on value change, we'll point it at our parent, and then we'll say our parameter is going to be window length, and if this parameter changes, if the value changes, we are going to want to call parent.initialize timer. So that way we're initializing the timer if we change our window length. Now, this timer is going to start our trail. So we'll want to pulse the trail whenever the timer starts. And then we'll want to, when the timer ends, copy our min and max values and add them to our selected channels table, or really like a new table that is, we'll probably just add to the selected channels table. Add our min max values there so we can use them to remap. So to do this, we can have yet another function, and this one will be called def how about trail pulse self. Now I realize that you could do this in many different ways, but I like to keep things pretty neat, so I'm gonna call another member trail 1, and then we will pulse our trail with self.trail.par.pulse.pulse, but I don't remember if it's called, no, it's called reset pulse. Reset to pulse.pulse. We're going to want to call that on timer start, and then def add min max to chan self min. Actually, no, we're just going to do self self.max equals op max. Oops, this should be min. Okay, so selected channels. Okay, so self.selected add min max to chan. So actually, I think I'm going to redefine this add channel function, and we'll just call the whole thing when we do listen. When we hit listen, we'll actually start the timer, and then after the timer ends is when we'll be adding our channel. So that's fine. So actually, this add channel is where we'll want to be doing this min or max. So here we can say min equals self.min channel min. and then make sure you do .eval so that we can get the most recent value from that channel. Now max will be self.max eval, and then we can change our append row to chan min max. Now we can change this. We can set up this override now, and we can just copy this code, put it right here. So we want to make sure that we're reevaluating our min and our max, and then here we don't want to append a row. We want our row that has channel as the first value. We'll take the second value, which is going to be the min, and set that equal to our min. And then we'll do the same with the next column and set that equal to our max. Now that should override. Now we have to change our listen chop execute. We don't actually need this chop execute anymore. Instead, we want these timer callbacks. So if we edit our timer callbacks, get rid of all of this, I'm going to, on start, call my parent dot trail pulse method. And then on done, we're going to return our add channel method. Just like that. So now when we press listen, we're going to be starting our timer. This trail then is going to be updating based on our timer. At the end of the window, the min and max values for our trail over that period of time are going to be captured and saved in this selected channels table. If we choose then another, say foot, and hit pulse, then we'll see that after our 4 seconds, we are again getting a range for our new parameter. Now let's see, what if I go back to ankle L? Where's that at? Okay, well, if I go back to ankle L, TX, and hit pulse, okay, so our override isn't quite working. Because when we're looking at our list for our selected channels, I bet if we debug this, we're going to see the problem. So if we debug that, and then look here, yes, we'll see that we're getting all of this because as our selected channels, because our text in this table now includes our min and max. So we can simply just grab a select top and just grab the, by index, first column, and then we can call this active chan list. And then all we can do, or all we need to do, is change this from self.selected channels to active chan list. And I believe that this should do it. Now, one, I guess, tweak on this is that we probably want to have our override, yes or no, happen before we start listening, not after. So maybe we want to reorder this to say, like, you know, when we click listen, first check for the overrides instead of, like you just saw, I click listen and now the override check happens after. So I can just say, yes, I want to override. And then if you just saw the top row here, updates. I'm going to leave as is just in the interest of time since this is a longer tutorial than I wanted it to be already. But that is something that I would probably change if I were you guys. All right, so now we've got our selected channels. We got our timer, all of that good stuff set up. So now we need to do the mapping. So to do the mapping, I will do a select. I'm going to grab our chan list, actually, because this is all of our channels with all of their values. We're going to convert this to a DAT and include our names. Then we're going to transpose. So now we have our columns and our values. Now we're going to use a lookup. We're going to wire all of our values into the second. And then we're going to actually grab our selected channels and wire that into the first. Now, the reason for this is because we're going to want to take whatever our selected channels are and then read in their active value. And the reason that we need to read in the active value is so that we can actually do the mapping, do the remapping. So we need this number, and then we need these numbers. And that is what we're going to try and build to. So we'll change this row index to row values. And now you can see that we're getting our real-time numbers for our Kinect values, but only for whatever our selected channels are. And if I choose a new one and we do listen, we'll see that appear afterwards. And now we're getting that too. So this is great because it has accomplished letting us choose arbitrary channels, map a min and max on an interval for those channels, record it, then easily grab the real-time values for the channels that we recorded. What's left is going to be doing the mapping. So to do the mapping, here's what we can do. I will middle mouse click here, and we're going to add an evaluate dat. Oh, actually no. First, we need a merge. So I will, after our lookup here, I'll do a select. I will select the index, just our values. Select just vals. And then I'm going to merge that as an append column. And then just to make things clear, I'm going to also middle mouse here and do another insert. I'm going to insert one row before the first, and the contents here, I'm just going to label. So it's going to be chan, min, max, val. And that way it just gives us something easy to be able to reference. All right, so now for the evaluate DAT. So for the evaluate DAT, this is basically going to evaluate whatever this expression is on every cell of our table. So it's like a for loop for all of our cells in our table. So for example, if I just say me.inputVal, me.input cell.val, then we'll see that we're just copying one-to-one. So I want my column 0, 1, and 2 to stay the same, and then I want to remap 3 to arrange 0 to 1 using these two values. So we're going to use some Pythonic conditionals inline here. So bear with me, and it should be pretty easy, and it's a cool trick. So like I said, we wanted to keep our input cell values for any column that's less than column index 3. So we'll say in our expression, me.inputCell.val, if me.inputCol is less than 3, else TDU, and then we're going to use the TDU module. We're going to clamp and remap. So we'll say TDU.clamp, TDU.remap, and here our val is going to be, the value that we remap is going to be me.inputCell.val, and the reason for that is because this section of the conditional is only being applied to column 3. We'll remap that me.inputCell.val from the value that's going to be taken from the same row, but column 1. So that will be me. We can access that value with me.inputTable, and then we can use bracket notation to access a cell in the table, me.inputRow, and then our min column index is 1. And we can copy this, 2, so that's our max. So we're remapping our input cell from our min to our max to 0 to 1, and then we'll clamp that on the range 0 to 1 as well. So let's show you the full code there. And now we are remapping all of these values from individual ranges for each channel to the range 0 to 1 for all channels. Now, to get this out, we can just do a DAT to CHOP and say, oh, actually, before we do that, we should select, and we'll actually need to do 2 selects. So one, we will select just the first column, and then the other, we'll select just the last column. And then we will merge those two columns, or those two DATs by appending columns. And so now we have just our channels and just our real time. And that can be our data. So this will be normalized input data. And actually, we can just change that to an out. And then we can middle mouse here, put a trail down. And now this will also let us see the trail for our last mappings, or for our active mappings. All right, so I said we were going to go through an interface for all of this. I actually think I'm going to do the interface in a separate tutorial because this one got a lot longer than I wanted, but I do think it's good, and I think that using chops and DATs, as well as expressions and callbacks, is really important functionality to be able to take things to the next level. So I think it's time well spent, but I'm going to stop here for now, and we'll follow up with the UI building component of this and where we can go next. So I guess before I totally leave today, so we need that parx for sure. Don't need that. Yeah, so actually I think this is pretty good. Yeah, I think this is pretty good for now. So I will actually just leave it here, and I hope that this was helpful. Apologies for all of the VS Code issues in the middle, and as always, thank you so much to all of my Patreon supporters. It's been really great to just have the growing support of the community, and it makes doing these a lot more fun. It makes motivation a lot easier, and just generally makes me really happy to see. So thank you guys so much, as always, and yeah, we'll see you soon.